So key features of functions. First thing that we're going to look at is the domain and range. And so the domain refers to the allowable values of X. So basically, what X values work within the relation. X values refer to your independent variables. In order to read the domain, you read the graph from left to right. Okay? So anytime you're asked for the domain of a function and you have it graphically in front of you, you look left to right. Okay? Tell me you're good there?
Yeah.
Okay. Okay, and then the range are the allowable y values in a relation. So this refers to your dependent variable. And in order to read the range, you look from bottom to top. Bottom to top.
Okay.
Okay. Okay, now we're going to do a little bit of practicing. Okay, on this first graph on your left, we want to identify the domain and range. So I'll model these two and then I'll have you do these two. Okay. So first one here, I'm going to look for the domain first. And I notice immediately that there are closed circles on the ends of both of the graph. And so I'm going to start at 0 on my x-axis, and I use a bracket because it is a closed inclusive starting point. Okay, 0 to 4 inclusive. Okay, notice I'm using a bracket. Bracket indicates that it is a stopping point and it's an inclusive value. And I looked at the graph from left to right along the x-axis. Now, range, I'm going to look at the graph from bottom to top. My lowest most y value starts at -2, and I'm going to use a bracket again because it's a closed circle. And I'm going to go all the way up to +2, and I'm going to stop it with a bracket. Okay? So because those are stopping points, I use brackets. And because they're filled in or closed circles, I use brackets as well.
Okay.
Okay? Okay, right-hand graph, I look from left to right. I notice that there's an arrow at the end. So that means for the domain, when I read from left to right, I'm starting at -infinity. And the reason why I'm starting at -infinity is because there's an arrow and that indicates no end. And I always use a parentheses when you use intervals with infinity or -infinity. You move all the way to 0. And do you see how it's an open circle here? See how that's an open circle?
Yeah.
So I'm going to use a parentheses there. That's my stopping point. So from -infinity to 0, and then I'm going to use a symbol that looks like this. Have you ever seen that symbol before?
I think so.
Okay, it means union. It's when you're joining a set together. So I'm going to say union, and I'm going to pick back up at 2. But do you notice how 2 is a closed circle?
Yeah.
So with 2, I'm going to put a bracket. And do you see how my arrow extends to the right? Where am I extending toward?
Is it positive infinity?
You got it, positive infinity, and I'm going to close it with a parentheses because again with infinity, you always infinity and -infinity, you always use parentheses.
Okay.
Okay? How'd you feel there? Did you range. I forgot I got to do range. I'm sorry. Range. Okay, so with range, again we start from bottom to top. And so I look at my graph And I notice that it starts at a positive 1. It does not go lower than 1. Now, at this portion of it, it's open, but this portion, it has it closed. Closed will always take precedence. So even though it's open at one value where x is, or excuse me, where y is 1, the other one that's closed will essentially fill it in. So we're going to start at 1 with a closed bracket. And do you see how the arrows are going up? That means you're extending towards positive infinity. So your range would be bracket 1 to infinity.
Okay.
Okay, do you have any questions about domain or range?
Yeah, so going left, is that negative? And then going right, is that positive?
That's correct. Negative infinity and positive infinity, yes.
Okay, thank you.
You got it. Absolutely. Okay, try this one for me. The one on the left. What would you say? Now, notice they're both open circles. What would you say for the domain from left to right?
Would you put a parenthesis?
Parentheses, where are you starting?
-5.
-5, comma, where are you stopping?
-2.
-2. And because it's an open circle, we would close it with parentheses. You got it. Okay, range, bottom to top. What's your lowest, most y value?
You put a parentheses and then -4.
-4. And you go up to,
+4.
and you close it with a,
parentheses.
You got it. Excellent. Okay, the one on the right, domain left to right. What's your lowest, most x value?
Parentheses with -4.
Good. And you go all the way over to where on your x-axis?
3 with a bracket.
Excellent. Okay, and range bottom to top. What's your lowest, most y value?
-4 with a parentheses.
Lowest, most y value, see here? -5 with a parentheses. And you go all the way up to?
Would it be 2?
2. Good. And because it actually hits at 2, what do we use to close in 2?
A bracket.
A bracket. You got it. Okay, how'd you feel with that?
I feel good about it.
Excellent. Okay, I think we have one more. Okay, determine the domain and range. All right, I'm going to let you take the lead. Now, this is a little bit of a tricky, choppier one, but I think you can get it. Okay, so we want to look left to right here first for the domain. Okay, so what do you notice your graph is doing as on the left-hand side?
Is it going to -infinity?
Yes. Okay, so you're starting from -infinity. Okay, you move, you move, you move. Do you see how it's closed here and it's open here? Remember how we said that closed takes precedence?
Yeah.
Okay, so we continue, 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 move, move, move. You've got another closed, but you've got an open, same x value. So keep going. And where's it going on the right?
Positive infinity.
You got it. So your domain would essentially be -infinity to positive infinity. Does that make sense with that one?
Yeah.
Okay, now your range is going to be different. Okay, range, you go bottom to top. So where are you starting? Lowest, most value?
-infinity.
-infinity. And where are you going to first stop at? Oh, I don't know why I put -2. Why did I put -2? I'm sorry. I don't know where that came from. That did not make any sense. -infinity, okay? And you're going, and where are you stopping at for your y's?
It'll be -1.
-1, good. -infinity to -1. And we're going to stop there. The reason why we're going to stop there is because do you see this big gap in the graph where I kind of highlighted? You see that?
Yeah.
Okay, so we stop at -1, and then where do we pick back up? What y value?
Is it 5?
Look at, let me use purple. See how we pick back up here?
Yeah.
Which would be what y value?
1.
1. Okay, so we pick back up bracket at 1. And do you see how, even though it's open here, it's closed here, and it's open here, but it's closed over here? And where's this arrow essentially going?
To positive infinity.
Positive infinity. So we're going to say -infinity to -1 bracket, union 1 to positive infinity. Does that make sense for range? Are you good with that?
Yeah.
Okay. You sure you're okay?
Yeah. When do you know that you have to use the union?
Good. So union is when you're joining two sets together. So basically, whenever there's a gap in the graph. So notice here, we used it because there was that gap from that -1 up to 1. Do you see how there's a gap there?
Yeah.
And then if we go back to this other one that we did here, do you see how there's a gap here?
Yeah.
So you use a union when you're joining two sets when there's a gap in the graph.
Okay.
Okay?
Okay.
All right. Let us keep going. I think we're on to the next key feature. Okay, next key feature is end behavior. Okay? So end behavior of a graph. Basically, that tells you it tells you what are the ends of the graph doing. Okay, so you're going to fill out two different statements when you're reading end behavior. Okay, now you can see it in different ways. This is how I typically read it. As x approaches positive infinity, f of x approaches, so y approaches, and then you're going to fill in the blank. And then as x is going toward negative infinity, y is going toward, and then there's a blank. So this is your notation that you'll see for end behavior. Now, you could see it flipped around, okay? It could say f of x approaches blank as x approaches positive infinity, or f of x approaches blank as x approaches negative infinity. It could be flip-flopped. It still means the same thing. You're reading as x approaches positive infinity, you're reading the y behavior of the graph. As x approaches negative infinity, you're reading the y behavior of the graph. Okay? So let's just look at this graph here that's shown to us. As x approaches positive infinity, which is here, where are your y values approaching?
Um,
Look at the ends of the look at the end of the graph. Where is it heading?
Positive infinity.
Positive infinity. And look at the other side. As x approaches negative infinity, where's y approaching?
Negative,
What'd you say?
negative infinity.
Okay, so look at, this is as x approaches negative infinity, that's this way. Look at the end of the graph. Where is it going?
Positive.
Positive infinity. See how it's both heading, they're both heading up?
Yeah.
Okay, let's do another one. I'm just going to open up really quick Delta, just so you can see a couple more examples with graphs.
Okay.
And then that way you'll just have a few different examples to look at. Sorry, I should have had it open. Okay. taking forever to load. I'm sorry, I don't know why. Okay. So let's look at this example here. So as x is going to, can you see my screen?
Yeah.
Okay. As x is going towards positive infinity, where do you see your y values going toward?
Positive infinity.
Good. And as x is going towards negative infinity, where do you see your y values going?
To negative infinity.
You got it. So look at your answer choices. See how it looks a little different? They start with as x approaches negative infinity. So as x approaches negative infinity, you said y is going negative. And as x approaches positive, you said y is going positive. So which answer choice would we pick here?
First.
The first one. You got it. You got it. Okay, let's do a couple more just to make sure you're okay with it.
Yeah.
Okay, well, this is the same thing. So we'll go to the next one. Okay, let's look at here. Okay, so you see the graph, this next one?
Yeah.
Okay, so as x approaches positive infinity, where's y going?
Negative infinity.
Negative infinity. And as x approaches negative infinity, where's y going?
To positive infinity.
Positive infinity. So which answer choice are you picking?
The last one.
The last one. You got it. Okay, let's do one more just to make sure you feel okay with it.
Okay.
Okay, do you see the graph here?
Yeah.
Okay, where do you see both ends are going toward?
Positive infinity.
Positive infinity. So that can help you kind of look at your answer choices. As x approaches positive, y approaches positive. As x approaches negative, y approaches positive. Which answer choice says that?
The third one.
You got it. Okay, do you feel okay with end behavior?
Yeah.
Okay, really quick, I just want to show you this trick. I always show my students this trick. And this is if you had to determine end behavior of a function and you were not given a graph, you were given an equation. Okay, let's say they just gave you an equation. Y equals blah, 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 right? Just an equation, and you had to look at it and you had to determine. There's a quick trick that I teach my students. Now, one is you could put it into Desmos, right? You could stick the function exactly the way that you see it. You could type it into Desmos and you can look at the end behavior. The other is a little trick I use. So I'm going to give it to you on this. So this is basically what this chart says, but I'm going to show you it even easier. So I tell my students the first thing you do is you look at the degree, whether it's even or odd. And then you look at the sign of the leading coefficient. So your choices are either positive or negative. So again, at the top, you look at degree, and E is even, O is odd. And then on the left hand of the chart, you look at the sign of the leading coefficient. Is your leading coefficient positive or negative? Okay. And now here's my little chart I teach. So I make a 4 box and I use up, up, down, 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 up, down. Okay, so even, degree, so 2, 4, 6, 8. So any leading highest power, whether it's an even number, okay, highest degree, if it's a positive and it's even, both ends of the graph will be going up. If it's negative, but it's an even degree, so it's a negative leading coefficient, but it's even, both ends of the graph will be going down no matter what. Okay, let me show you that on Desmos, just so you kind of get an idea what the heck I'm talking about.
Okay.
So we'll just show you a couple examples. Okay, let's say we had y equals 3x to the fourth. Okay, do you see how both ends are going up?
Yeah.
Okay, positive leading coefficient, it's a positive 3. The degree is even. What about if I turned it to a negative? Do you see how both ends are going down?
Yeah.
Okay, so I'm going to change this. I'm going to say to the power of 6. Both ends are going down, still a negative. I'm going to change this to a positive 4. So a positive leading coefficient with an even degree, both ends are going up. A negative leading coefficient, I'm just going to do negative leading coefficient with an even degree, both ends will go down.
Okay.
Okay, now I'm going to go back and do odd. When it's an odd degree, but it's a positive in the front, then the left hand will go down, the right hand side will go up. When it's negative in the front, but it's an odd degree, it's going to flip-flop. Up on the left, down on the right. Okay, let's show that in Desmos. So I'm going to change this to an odd degree. I'm going to use, let's say, 5. Okay, look at a negative leading coefficient. I just have a -1 there. I'm just going to do -2. Okay, see how it's up, down? And look at our chart. Negative, odd. Do you see our chart here? Up, down?
Yeah.
Okay, but let's say it was a positive in the front with an odd degree. I'm just going to take that off. Down, up. So as x approaches positive infinity, y goes up. As x approaches negative infinity, y goes to negative infinity.
Okay.
Okay, now when would you use this? If you just had to quickly look, if I said to you, let me just give you one more example. Let's say I said y equals 3x squared plus 5x cubed. Okay, and I wanted you to tell me the end behavior of this graph. First of all, what's your highest degree there?
3.
3. Is that even or odd?
Odd.
Okay, is the leading coefficient in front of that positive or negative?
Positive.
Okay, so we're going to fall here. We're going to find our end behavior. As x approaches positive infinity, where's y going?
Negative infinity.
Remember, read this would be considered positive infinity because it's on the right hand side of the graph. This would be considered the left hand side of the graph. So as x approaches positive infinity, where's your y going?
To positive infinity.
To positive infinity. As x is going towards negative infinity, where's your y going?
To negative infinity.
To negative infinity. Okay, does that make sense? Are you okay with end behavior?
Yeah.
Now, if you don't want to remember that chart, or you're like, I'm kind of like on the fence about the chart, remember, you can always type the function into Desmos and look at the end. Look at the end behaviors. Okay? Okay. So like on the work I give you, the practice problems, I'm going to do end behavior graphically, but see how it says end behavior algebraically?
Yeah.
They're just going to give you a function here. You can, again, just use that little chart or type it into Desmos.
Okay.
Okay? Okay, you good to move on?
Yeah.
Okay. Okay, intervals of increasing, decreasing, and constant. Okay, for interval notation, for intervals of increasing, decreasing, and constant, you always use interval notation. So you're going to use parentheses. And you use the x values to describe what y is doing. Okay? So make sure you have down for intervals, increasing, decreasing. Now, we won't see constant very often because constant means it's just going to be a flat piece of the graph, right? You'll see that more when you go to pre-calculus. But for math 3, you're really going to just look at increasing and decreasing most frequently, okay?
Okay.
Okay, so here's how we read it. I'm going to start on the left-hand side of the graph, all right? I tell my students it's like riding a roller coaster, all right? So watch my roller coaster here. I'm going to use blue. So I start from the left and I'm going down and I have a turning point, right? So from negative infinity to -2, right? Because that's where I stopped on my x values. What are my y values doing?
They're decreasing.
They're decreasing. Good. Okay, a lot of students get mixed up about that because they see the arrow going up, but remember, you're coming from the left, so you are decreasing. Okay? From -2 to 0, what are your y values doing?
They're increasing.
Increasing. So we said decreasing, then we said increasing. Okay? From 0 to 2, what are your y values doing?
They're decreasing.
Decreasing. And then from 2 to infinity, because you're following the x-axis, what are your y values doing?
They're increasing.
Increasing. Perfect. So I always say it to my students, you ride the roller coaster. You decrease, increase, decrease, increase. Does that make sense?
Yeah.
Okay, let's do another one. Find the intervals of increasing and decreasing. Okay, so we're going to look from left to right. Okay, it helps too if you kind of in your mind indicate where are my turning points, right? Because a turning point is going to be a change in direction of the graph, right? Change in direction. So this is a turning point and this is a turning point. So you know you're going to change whether you're increasing or decreasing. Okay? So from negative infinity to -2, what are your y values doing? Oh, did I lose you? Oh, there you are. So, what'd you say?
Increasing.
Increasing. You got it. From negative infinity to -2, you're increasing. From -2 to 0, what are your y values doing? Decreasing. And then from 0 to infinity, what are your y values doing? Increasing. A lot of times you'll see union, like, so in this particular example, there's 2 intervals of increasing. And so you may see your answer as union 0 to infinity. And so what does that mean? Remember, we said that the idea of union is just joining 2 sets together. So we're saying from negative infinity to -2, and then from 0 to infinity, your intervals of increasing. Okay? And then there's only one interval of decreasing. Okay. Next is the idea of relative or local maximum or minimum. Okay. So basically what this concept is when you have a function like a cubic function, right, where it's going towards positive infinity and negative infinity in either direction, there's not going to be an absolute maximum, meaning a specific set point, and there's not going to be an absolute minimum, but there's something called a local max or a local min that's just the highest point relative to those around it. Those are going to be your like humps and valleys. So like here, that's going to be what's considered a relative or local maximum. And that's going to be the ordered pair 0, 5. Okay? 0, 5 is the relative maximum of this graph. It's not the absolute. It's just the highest point compared to those around it. What do you think the ordered pair is of the relative minimum?
3, 1.
You got it. So the minimum would be at 3, 1. Perfect. Okay? And that's just as simple as that seems. Relative max is your kind of like hump in the graph. Relative min is going to be your valley or dip in the graph. Okay? Okay, intercepts. Very simple. X-intercepts are where the graph crosses the x-axis. Y-intercepts are where the graph crosses the y-axis. That's kind of self-explanatory. I'm sure you've seen that before. Can you name for me the x-intercepts of this graph here?
-3, -1, 1, and 3.
Good. -3, 0, -1, 0, 1, 0, and 3, 0. Perfect. What is the ordered pair for the y-intercept?
0, 9.
0, 9. Perfect. And why can a function only have one y-intercept? Because if a set of ordered pairs is a function, what can't repeat? Which values cannot repeat in a function? The x values. So you're not going to have more than one y-intercept, right? Because you don't have more than one x value that's the same.
Okay.
So it's only going to have one y-intercept, 0, comma, whatever it is. Okay? Okay, let's look at, we have this one, and then, yes, perfect. Okay, we're on good pacing here. Okay, we're going to look at pretty much all of the things that we did today. Intervals of increasing, decreasing, x-intercept, y-intercept, domain, range, relative minimum, and relative maximum. Okay? Okay, intervals of increasing. Where on this graph would you name your intervals of increasing? From what x values to what x values is the graph increasing?
From -1.92 to -0.56.
You got it. And then I'm going to hit union because there's one more interval where it's increasing. And where would that be?
0.232 to 0.69.
Okay, so remember 0.232 and see how it's kind of just going up?
Yeah.
Going up. So it's going toward from 0.2. Go ahead.
Positive infinity.
You got it. So on your x values from 0.232 to infinity, your y's are going up. Perfect. Okay, decreasing. Tell me those intervals.
The positive infinity.
Okay, remember you're coming from the left, so that even though your arrow's going up, you're talking about your x values. So you're coming from negative infinity on the left. And where are you stopping?
At -1.92.
Good. union, there's one more interval of decreasing. What would that be?
Negative 0.56 to 0.23.
You got it. Awesome. Good job. Okay, y-intercept. What's your ordered pair for your y-intercept?
0, negative 1.
Good. What's your ordered pairs for your x-intercepts?
Negative 2.5050 and 0.69 and 0.
0.690. Awesome. Okay, so you've got those down. Domain, x values. What would be considered your domain for this function?
Would it be negative 2.505?
Okay, remember, see how it's going up on both ends?
Yeah.
So that means where are you essentially coming from? Negative infinity to positive infinity. You got it. Awesome. Okay, range, bottom to top. What's your lowest y value that this graph hits?
Negative 3.038.
And where is it going up to?
Positive infinity.
You got it. Perfect. Okay, relative minimum, relative maximum. So this one's a little tricky because some teachers there's kind of like a gray area here. Some teachers consider, like, when I see the word relative, I'm thinking it's the relative lowest point or highest point compared to those around it. This is your absolute minimum because that's the lowest point that the graph hits forever, right? That's the lowest, lowest, lowest. That's absolute minimum. What would be considered a relative minimum here?
Would it be the negative 1.138?
So remember, you're looking for your dip in the graph, your dipping point. I'm sorry. I completely misheard you. I'm sorry. So yes, you were right, except you want to use the whole ordered pair. So, yeah, I'm sorry. I thought for some reason I heard you say the y-intercept, or I thought I heard you say that. Sorry. Having a moment here. So it would be 0.232 comma negative 1.138. You got that. Excellent. What about what would be considered your relative maximum here?
Would it be negative 0.56?
You got it.
Negative 0.555.
Yes. Awesome. Good, good. Okay, how do you feel with that? Okay?
Yeah.
Awesome. Okay, so we have that one, and then we have, okay, let me go because we only have 5 minutes. I'm going to skip over this one since we did one whole example of everything. I think you're probably good with it, and I'm just going to go to the concept of even, odd, or neither. Okay, that way we can do that, and I think that, I didn't get to positive or negative. Okay, that's all right. I'm gonna try to do these last two skills. Okay, so even functions are symmetric to the y-axis. Do you see these 3 picture examples here?
Yeah.
Okay, so you want to know that if a function is even, it's symmetrical. Did I spell it right? Symmetrical to y-axis. So basically, you can fold it over the y-axis and it'll fold onto itself. Okay? For odd functions, it's symmetric to the origin. Symmetric to origin. Okay, so that's a little bit harder to tell, but basically if you look at your 3 picture examples here, if you did like a rotation of it about the origin, it would flip onto itself. Okay?
Okay.
Now, there's one other way to determine even, odd, or neither. When you plug a negative 1x into the equation, if it comes back to be exactly the way it was originally, it's going to be even. If it comes back to be exactly opposite, it's going to be odd. If it does neither of those two things, it's neither. So this is like a surefire way if kind of the visual or spatial recognition is a little tough for you. Plug negative 1x into equation, and if it comes back to be exactly the same as the original, it's even. If it comes back to be exactly opposite, it's odd. So look at this first example. So here's my original, x cubed plus x. I plug negative 1x in both spots. I simplify and I get y equals negative 1x cubed minus x. Look at the original equation. Is it exactly the same?
No.
Is it exactly opposite?
It's the opposite.
It's exactly opposite, so it is considered an odd function. Now watch this really quick in Desmos. I'm going to type it in real quick so you can see it. X to the power of 3 plus x. Do you see how it's like symmetric with respect to the origin? Do you see how I could like flip it and it flips onto itself?
Yeah.
Okay, perfect. Okay, let's do number 2 here. I'm going to plug negative 1x in for x. So negative 1x squared plus negative 1x minus 3. Okay, negative 1x squared just comes back to be x squared. And then this turns to minus x minus 3. Is it exactly the same?
No.
Is it exactly opposite?
No.
So this is neither. This is not even or odd. Okay, lastly, let's check number 3. We're going to plug negative 1x to the 4th plus 3 times negative 1x squared. Okay, anything to the even power will always turn positive, right? So this is just going to come back to be x to the 4th, and then this is going to come back to be 3x squared. Is it exactly the same?
Yeah.
So it's even, it's symmetric to the y-axis. Watch this in Desmos. X to the 4th plus 3x squared. See how it's even, or it's symmetric to the y-axis?
Yeah.
Perfect. Okay, I know our time's up. I just want to do one more thing really quick. I just want to talk about the concept of a positive interval versus a negative interval. Very simple. Positive means the graph lies above the x-axis. Negative means it lies below. So where is this graph positive? It's positive from negative infinity to negative 2. Okay, look, see this whole part of the graph lies above the x-axis? And then the other positive interval would be 3 to infinity. Because from 3 to infinity, it lies above the x-axis. So positive, you go above, negative, you look below. So what would your negative interval be here? From what x value to what x value would the graph lie below the x-axis?
Negative 2 and 3.
Negative 2 to 3. Perfect. So I'm just going to write down here the negative interval is from -2 to 3 because that lies below. So the concept of positive versus negative, positive has to lie where?
Above the x-axis.
Above the x-axis, and negative has to lie
below.
Below. You got it. Okay, I'm going to stop us. Perfect timing.